Hi, today I want to talk and explain about something that is called Optocoupler. So we are talking about Optocoupler. Okay, so what is Optocoupler? So basically Optocoupler is something like this. If you can see, this is a tiny chip with 4 pins. How it goes with the 4 pins inside. So let's say this is our chip. So we have pin number 1, 2, 3 and 4. Usually the first pin 1 and 2 are just a LED. This is internal LED. So in order to activate the LED, of course you need to supply to the LED a voltage and the current. And in order to be able to see what happened, so in the other side you have something like this. In the other side you also have to supply a voltage and a current, something like this. So the output will be here. Now, what do we need it, what is it good for, and what are we doing with it? So optocoupler is used to isolate. This is the main reason to use it. What does it mean to isolate? It means that we have in our circuit 2 different sides that we want to isolate between them. And what is the isolation? Isolation is in, of course, kilovolts. Sometimes they are written 5 kilovolts, sometimes 8 kilovolts, and sometimes more. What this means that if you will have a very high voltage in one side, it will not affect the other side. This is the meaning of the isolation, and usually we need it in power supply where we have the main voltage and the output voltage, and we want to isolate between these 2 circuits. So the isolation is here inside. There is isolation for high voltage, but the light can emit from this side to this side. About how to check that our optocoupler is working. This is something pretty simple to do. First thing, we need to make sure that this LED is not burnt out and that it is working, of course, properly. So we will need to supply the correct voltage. Usually the LED voltage is something between 1.5 volt to 3 volt, something like this. And we have the current. We have usually a peak current and the regular current. So it can be, for example, 20 milliampere for working, and it can survive peak of 1 ampere usually. And on the other side we can supply a voltage. So we have a emitter and collector. This is the collector and the emitter. So we have VCE maximum. VCE maximum, for example, can be 35 volt, can be 50 volt, and can be higher, which means this is the voltage that if we will supply to the sides that receive the light, it will still work properly. So how can we test this? For example, just for the demonstration, we will build a circuit. We will apply current to the LED, for example 20 milliamp, and then we will measure the voltage here. So how we will know that it is working? Very simple. When we are not supplying voltage to the LED, which means this part is cut, so we should see the voltage. For example, if the VCC here is 10 volt, and we will measure with a DVM, for example, the voltage here, so we will see 10 volts. And then when we will activate the LED and the current will flow, so the light will transfer from the LED to the receiver, and when it go from here to here, so current will start to flow inside the receiver. When current is flowing, so the internal resistance between the collector and the emitter is low, and for example, let's say the resistance is now 10 ohms, and here we have 10 kilo ohms. So basically, when will be a light in the receiver, we will then need to see a voltage of something very close to 0 volt. For example, 0.1 volt here. Of course, this depends on the resistor that we put here and the voltage that we supply. This is the only thing how this is working. This is very simple, and a few guys asked me how this is working, so I thought to do a video about it. So let's now connect our optocoupler. I don't have the datasheet of this one, and I'm not going to try to read it. We will just assume that the circuit here is the correct one. Usually it is, and we test with a DVM to see if the theory that we just spoke right now is working. So I will prepare the circuit and then we'll test it. Okay, so here is the circuit. I've built it. Of course, there are few things that you don't want to do. For example, I've used the same VCC here and here. Of course, this is not the idea. The idea is that VCC on one side should be different than the other side, because this is all the isolation. Also about the ground, I use the same ground. This is just for learning, but of course you need to isolate the VCC and the ground on this side from the VCC and the ground on the other side. Okay, but in this demonstration they are the same. Okay, so what I did, I connect this ground to this ground. This is the wire that we see here, the green wire. This is of course just the fluke, so I'm measuring the output here on our circuit, and the ground is the same ground for all. So this is the fluke ground, and this is my power supply ground. I have a resistor of 600 ohm, and the voltage is 10 volts. I've limited the power supply to 1 milliamps. If it will be higher, but let's see if it should be higher. We need to divide, of course, the voltage by the resistor and decrease the voltage of the LED, but this is not important. I put a resistor of 560 ohm here, and here I'm using 33 kilos instead of 10 kilo. Now you can see the voltage is 10 volt because I didn't yet connect the LED. Now I will take the resistor and I will connect the LED, and when I'm connecting, so we can see that the voltage decreased to 50 millivolts. Okay, how can I see the voltage in millivolts here? Here millivolts, sorry. Okay, so we have 51 millivolts, and when I am disconnecting the LED, so the voltage of course now is 10 volts, the power supply voltage. Again, connecting the LED, internal LED, and current start to flow and the voltage decrease. By the way, the current now is exactly 20 milliampere. So this is exactly usually the voltage that is rated for the internal LED. So this optocoupler eventually is working properly, and this way you can measure it yourself. Hope this was useful to anyone, and that's all. Thank you and bye.